And so make sure by the end of today that it is indeed on GitHub correctly. So let me just show you an easy way to check to do that. I'm just going to go to GitHub. You won't have nearly all the stuff that I have, but that's great. Right, but probably what you have on the right side is just your repository on GitHub. So what you should have on the right side is just your repository. I have everybody's, but I'll just pick mine, which looks a lot like yours. And in that repository will kind of be a mirror of all the folders and files that are on Cloud9. So your goal is to get your assignment, which is on Cloud9, to GitHub, which is where I grade your work. Okay, so what you want to do is you want to click on the assignments folder. All right, I might say assignments 1, both of that's okay. Click on the assignments folder. I'm going to go into assignment 1, right? And I'm looking for your code to be inside of this guessing game file. Right, so I'm looking for your code to be inside of this guessing game file. We can click on it. I'm going to click on it in a minute. You also say over here, right? It says 17 days ago. So if you wrote your assignment more recently than 17 days ago, then you probably know that I don't have your most recent copy. Right, so you're looking for something that's like 5 days ago or something like that. But if you click on that actual file, guessinggame.cpp, right, you'll get all of the code that I'm going to see and that I'm going to grade on. So you'll get all the code that I'm expecting to see and grade on.
So it should be in repositories, right?
So it should be right in GitHub under your repository, yeah, under assignments. So if right at the opening comment block's not filled out, probably you didn't get it correctly, although some people forget to do that. But if I look down this code here, that code hasn't changed, right? So we're going to be seeing change code on Cloud9, right? You haven't taken that code and given it to me on GitHub. So today, take a look in lab time. If it's not there, right, call me over and let's make sure it's there. This is how we'll turn in all of our assignments. So this is assignment 1 out of basically 5. So we'll do this 4 more times. This time, turning it in on there. You don't have any questions about that?
You resubmit just.
Yeah, you resubmit just overwrite. So Git and GitHub is actually a versioning control system. So the whole point is for you to rewrite over everything.
If we say I didn't like how not clean my code was,
Yeah.
and I cleaned it on GitHub, you see that it's...
Whatever on GitHub is what I see.
Okay, so if I've cleaned it on GitHub, then you get to see that too.
Right. Now, right, because you like an editor, whatever, right, they let you do that now.
Yeah.
There's like an edit button. Do know, though, that the next time you try to push from Cloud9 to GitHub, it's not going to let you do that until you pull the new changes. So basically, you have files in 2 places, and it doesn't know how to like mismatch.
So I have to figure out how to send my clean GitHub file to the SIG. Okay.
Which is it's pretty easy.
Maybe that'll be my lab question.
That's right. Exactly. Cool. Any other questions? All right, let's talk about this stuff. But before that, let's just talk about how we create variables, which is pretty easy, right? We should be really good at it now. Right? Things like int x gets assigned 5. Right? And there's a lot just in that little statement, right? Int is our types, right? And the 5 types we should know are ints, doubles, what else? Bools, strings, and characters, right there. Right, so the big 5, right? Int, double, char, string, and bool, right? That's it, those 5. Right? I mean, there's more, there's longs and shorts and all that kind of stuff, floats, but we don't really care about it. Right, those are the 5 you want to memorize. After that, write the name of our variable, right? The assignment, operator, and then 5. Put 5 into that box. Right, okay, so today we're going to talk more about what we can do with variables. Right, because variables are kind of the basis of everything we do, so we'll talk more about that. And then even though you did input and output in your coding assignment, we'll formally talk about how it works. Give us just a better overview of all that. And then we'll be done. Today's lab, I didn't put you guys in partners today because today's lab's a little bit shorter. So you should be able to do it on your own. But if you need in lab time, you're more than welcome to talk to your neighbors and get help from them, get help from me. All that stuff. Sound good? We can handle it?
Hell yeah.
On the modules 4 and 5 will set the grade and should custom 4.
It is for today, but everything's always due Thursday. So yeah, that is today's lab, today's lab time, right? Follows today's lecture and it's all the same stuff, but technically it's not due until Thursday. But yes, that is today's lab. All right, we're gonna talk about all this fun stuff. So first we're gonna talk about the increment and decrement operators, which are pretty basic, but we'll look at some ways that we can use it. And you remember what operators are? Stuff that does stuff, right? Symbols that do stuff. Symbols that do things, right? That's good, I like it, right? And so we're gonna talk about the increment operator and the decrement operator. The increment operator, because it's an operator, it's symbols, right? In this case, 2 plus sign, right? Anyone know what the plus plus does?
Adds 1.
Adds 1 to a variable, and what else does it do? Stores it back in the variable. That's a key thing, right? Add 1 to a variable, right? But that doesn't automatically store it in a variable, right? So add 1 to this variable and store it in that variable, right? You can put the plus plus before or after the identifier, right? The name of the variable, and we'll see examples of that. Right? Decrement operator, instead of being plus plus, it's what?
Minus.
Instead of adding 1 to a variable, it subtracts 1 from a variable and stores, right? And once again, you can put it either before or after that name. Right? So let's look at an example. Right? If A gets assigned what?
1.
1 and B gets assigned
7.
I don't have an eraser. Right? How many variables did I create? 2. Both of type what? Integer. Good. Are they well named or badly named?
Terribly named.
Terribly named, right? But they'll work for our example, right? They are terribly named because they don't provide anything. But I don't really need anything for them, right? So I get 2 variables, right? One called A, whose value is 1, and one called B, whose value is 7. Heard with that? They hold integers, right? The values that we put in them, we call those literals, right? The values that we put in them are integer literals. And then I can do something as easy as this, A plus plus and a semicolon. That says add 1 to the value of A and what else? Store it, right? So add 1 to the value of A, so it becomes what? 2. And I overwrite it, I store it. Because the key about the store is that if I just say A plus 1, that adds 1 to the value of A, agreed? But it doesn't store it, right? It just makes that a value, and then you need to choose what to do. All right? A plus plus is the same as saying A gets assigned A plus 1, or A, right, plus equals 1, right? And A plus plus. All 3 of those things mean the exact same thing. Add 1 to your variable and store it.
And that's only ever going to do it once, unless you're like in a repeating loop.
Right here, right? So this plus plus and minus minus becomes very powerful once we get into things like loops where we need to really count. And in code, we count a lot. So that's why with this plus plus helpful. But all 3 of those things do the same thing. This obviously is the shortest way of doing it.
And you can throw a number after that plus plus.
Nope.
By more.
Nope. Only add 1. So if you wanted to increment by more, you would do A plus equals. Good. All right. I can also do minus minus B. What does that do?
Subtract 1.
Subtract 1 from B and store it back into B, right? Trying to show you that the increment and decrement operator can go after the identifier or what? Before, but not both. You can't like say plus plus A plus plus. Doesn't work. All right. So we know what the value of A is, right? We know what the value of B is. All right. Everyone good with why C++ is called C++? Right? C++ is a superset of C, right? So we took C and we what? Added a 1 to it, right? So we'll do that. C++.
I'm not sure if you can get to it. Are you moving on now from the question?
We're gonna do, no, we got a couple more slides on it. Right? So you can use these operators, right? The plus plus, minus minus, and expressions. What are expressions? Right? They're kind of like statements, right? But they're right either math expressions or some expressions with operators that eventually become one value. Okay, so the goal of an expression is that you take whatever's happening and make it into one literal value. Okay, so let's look at how we might be able to use these things in expressions. So 2 times A plus plus is an expression, right? A mathematical expression. Right? right? 2 times a plus plus is going to give me how many values? One value. That expression always gives me one value. Now, because I'm also using the increment operator, it's really doing 2 things. It's adding 1 to the value of what? A, and also figuring out 2 times whatever the value of A is. All right, everyone good? I'm doing 2 things at once. Good to try to confuse it. Now, what's the value of A right now?
2.
2, right? So I'm saying 2 times A plus plus, and the order of your plus plus, whether it comes at the beginning, like we call that prefix notation, or at the end, postfix notation, changes how this expression works. So if you see A plus plus, when you use A in that expression, you get the value of A first, because that's what comes first, and then later on you increment the value of A by how many?
1.
1, just 1, just 1. Right? If it came before, right, 2 times plus plus A, right, do you get the value of A first, or do you increment A first?
You increment A
Increment, because the plus plus comes first, right? So we're going to increment the value of A first and then get the value, which changes, right, the answer to my expression. Right, by putting it before or after, it changes the answer to my expression. Right, so let's look at this example. Right, we don't have B anymore. Right, but we do have what? The A and value produced. Are we good with that? Let's do the left example first. Right, we say value produced gets assigned 2 times plus plus A. All right, and so because the plus plus comes first, what do we do to A?
Add 1 to it.
Add 1 to it. So A becomes what?
3.
3. Right, A becomes 3. And then in that expression, we say 2 times A, and A's value is? Well, A's value is 3. Right? You're a step ahead. That's good, right? And so 2 times 3 becomes 6. And assignment operator says take the thing on the right side and put it into the box on the left side. And so value produced becomes 6. Easy enough? Right? Everyone see that the value of A became 3? Right? But the expression evaluated to 6, right? 2 things happen, right? We stored, right, incremented the value of A, and we also, right, got some mathematical expression and stored it into value. So 2 things happen now. Let's look at the other example. So A, once again, is 2. Right? There's no value produced yet. It's all garbage for now. And now we say 2 times A plus plus. So what comes first?
A.
A. So the value of A is? 2 times 2 is what?
4.
4. What do we do with 4?
Add 1 to it.
No, right?
Store it.
We don't add 1 to it. We store that value into what?
A.
Value produced. Right? Everyone see that? The expression on the right side of the equal sign, right? We're going to figure out what that value is, and then we're going to assign that value into value produced. We take 2 times 2, which gives me,
4.
and we assign that to value produced. So value produced becomes what? 4. And then, right, independently of that, what happens to A? You add 1 to it, and it becomes
3.
A is 2, right? It becomes. It's a little confusing. That's why we're talking about it. Right? Plus plus minus minus will only act on one variable, the variable that it is on. So no matter which place you put it, at the end of either of these, A will be 3. So it started as 2, and you did what? You added 1 to it. But then you also use the value of A to figure something else out, and that value of A depends on if you're going to increment it first, plus A, or increment it afterwards, A plus.
So in these scenarios, if you were to now call on A in a second line, it would be the value of 3 that you're
Yes.
using? Okay.
Yeah, so if I see out at A, it would also 3. If you don't want to be confused, what could you do?
Write it out.
Kind of write it out, right? Don't do both of them on the same line, right? You want to increment A first, just say A plus plus, semicolon, and then say 2 times A on the next line. Right? You want to increment A afterwards, right? Do your expression, and then afterwards say A plus plus. Right? But you need to know what happens in this situation. And that's an important thing for us to know, right? And just, it's the order that you see the operators. Do you increment A first, plus A, or do you increment A afterwards, A plus plus? Right, the order. Question on that? You? That is one question. Very So there's a lot of things you can't do, right? You can't say x plus y plus plus, right? Because the increment operator works on how many variables?
One.
One and only one, right? If I wanted to say x plus y plus plus, what would I really write?
X plus plus y plus plus.
If I wanted to change both variables, x plus 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 y plus plus, or if I just wanted to add 1 to the answer, x plus y plus 1. Right? So think about what you want to do. So you can't do that, can't do that, right? That's just ridiculous. Don't write plus plus 5, what would you write?
6.
6, right? Don't be dumb. Don't be cute. Just write 6. Another one. Questions so far? All right, one last thing to talk about, and that's the fact that the order of sub-expressions is not guaranteed. So we're barely understanding what expressions are, and now I'm talking about sub-expression. But a sub-expression would just be an expression inside of an expression, right? So let's look at something like this. A's value is 2, and then I'm going to take A plus A. Okay? Now we know plus A is going to make A's value what?
3.
3. But the question is, this A, was that value 2 or was that value 3?
2.
Why is it 2? Well, it seemed to come first, right? But what does this line say? The order is what?
Not guaranteed.
Not guaranteed. So there is no guarantee that it's 2. In fact, it could be 2 or it could be what? 3. It could be either, right? So is it really 2 plus 3 is 5, or really is it 3 plus 3 equals 6? Both. Both. And none all at the same time, right? Undefined. Should you write code that is undefined? No, so don't write crap like that. It doesn't work. Don't try to increment a variable and use it in the same expression. It doesn't work. Right? Well, it will work. That's the worst part. It will work. It will compile.
Well, it'd be
But it might
different
work
every
one way on
time.
someone's computer and different on someone else's. It's not provided specific. It's because it's not in the specs. So the specs don't tell you what to do in this situation. And so it's open for interpretation. And most code and computer shouldn't be open source. It's a bad thing.
Most.
It's a real bad thing. So we'll write it. We'll see what the answer is, at least in Cloud 9. Questions about this, operators? Right? Plus adds 1 to a variable, minus does what? Subtract 1. That's really what we're trying to look at.
What is this lecture?
So I've created already a lecture 4 file. So I created a lecture 4 file. Everyone good that, once again, these samples that I'm doing exist in the lectures folder, right? I might change them, right, a little bit, depending on my mood. But for the most part, they're really close to what's in there. Well, yeah. But I'm also not deleting them. You can always come to my workspace and look at them. So they're there, so I'm not deleting them. Okay. So, right, if I want to increment variables, what do I need first? A variable, good, right? Good answer. I better create some variables before I increment them. Right, and so let's just do that. We're going to do the amazing example we just did. Int A is 2, right, value produced, right, is, well, not int. How many storage spots did I create? 2. And then we say value produced, right? It's assigned 2 times A plus plus. Because I don't have a value for it, right? I didn't initialize it because I knew, like, on the next line that I was going to. If you want, you could 0 initialize it. Just 0
Chris, what kind of graphics card do you have?
I think if your compiler should give you a warning that you try to use an uninitialized variable.
1070 Ti.
What's the value produced?
Not bad.
No, it's not bad.
$5
graphics card.
2 times something. That would be
On
fine.
Memorial Day for like 375.
Right?
It's pretty good.
Yeah.
Well, let's see what comes first. Does the plus come first or does A come
Find
first?
it a little cheaper.
On line 12, 2 times A plus plus. What comes first? A. So you get the value of A. The value of A is 2. 2 times 2 is 4. So value produced becomes 4. In addition, the value of A becomes what? 3, right? So don't try to apply plus plus to the whole expression. It's not part of the expression. It's doing its own thing. It's changing just the value of A. So we see that the value of value produced is 4, right? And the value of A is 3. Now if I just take my code, right, and I take off, or I put the plus plus in the front, right? Remember, you can't have it on both sides. Right? The value of A is still going to be what? 3, right? The value of A is still 3 because I took A, whose value was 2, and I did what? I added 1 to it. Right? But here, because the plus plus comes first, when I say 2 times plus plus A, we increment A first, so 2 becomes 3. 2 times 3 is? 6. If I run that, I should, right, to get 6. But the value of A is still what?
Wait, so you just run it again and it stays storing as that value?
Yeah, every time I run my program, it starts at the beginning, and so it resets all my values to level. Right? A was 2, right? I recompiled, so.
Oh, I get when you switched your plus.
I switched it, right? It was A plus plus, and now it's plus plus. Okay.
Makes sense.
And then, right, I'm going to put A here. A times plus plus A, right? My answer is going to be what? Either what? What do we think?
9 and 3.
9 and 3? Well, not 3, right? It could be 9, because A could be 3.
Well, I mean, I ran it for 9 and 3.
Now we'll see. What do we got? We run it, right? I get 9 and 3, right? The 9, because it treated that A, whose value seemed to be 2, but it treated that value as what? 3, right? It treated that value as 3.
So it did the plus plus A first, and then went.
So I did the thing on the right, where did the thing on the left?
So it went choo 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 choo.
Yeah. Remember that order is what?
Not guaranteed.
Right? So should you write code like that?
Not really.
Not a good idea. Yeah, it should give you 9-3 every time. Because the compiler is parsing all your code the same every time, so every compiler will do it the same. The different compilers will do it. All right, let's talk about typecasting. Right? What are types? What are types? Different kind of things we can store, right? We have all 5 of them right there that we like to talk about, right?
Yeah.
Integers, floating points, characters, booleans, and strings, right? So those are types. What's casting?
A way to change a value from one type to another.
Yeah, right. So we're going to learn that for casting for us is changing types. Changing types. Are you just reading my slide?
Yeah.
The typecasting is changing from one type to another. So we're talking about like going from an integer to a double, or a double to an integer to a character, that kind of stuff. Right? So for example, right, I have 2 variables that both are of type what?
Int.
Good. So when I say x divided by y, I'm saying how many times does y go into x? What's my answer? 4. And just 4, right? I want to agree just 4. Because an integer divided by an integer gives me a integer. Good, right? So my answer is 4. Okay. What do I need to do to get 4.5? Change what to a double?
Integer value.
I change that?
Yeah.
Okay. Right, either value, either x or y somehow need to be a double. Okay. Well, what if I told you that x and y are supposed to be integers? Like they shouldn't ever be floating point values, so I don't want to make them double. Result could be a double, but still, when I did my division, it's integer division. Yeah, right? You're like, let me read the slide. It's in there, right? Somehow, though, I need to make either x or y a double, but just temporarily, right? And so that's how that's the idea of static casting.
Could you multiply by 1.0?
You could, right? So you could say parentheses x times 1.0. Right? Have that happen first and then divide by y. That would work, right? Or, right, what we can do is this idea of static casting. Static casting is the idea of type casting from one type to another. All right? And so think of static cast as a machine, but you put some value in, you get some other value out of it. All right? What we're saying is that the value you want to get out is of type what? Double and the value we're putting in is y, but not y, the variable, but what? The value that y holds. Okay, and so we put 2, right? We put 2 into the static cast double machine, and what do we get out of it? Not 4.5, we get 2.0 out of the machine. And then 9 divided by 2.0 gives me 4.5. So this temporarily changes the value inside of a variable, temporarily, right, one time. That way I can maybe use it in things like floating point. Does that make sense a little bit? So static cast is always the same thing. Double is the type you want to change it to. And then the parentheses is the value or the variable, which holds the value that you want to change to that.
Why wouldn't you just write it the way you would need it?
That way, the result to come out in double.
Well, because I wanted x and y to be integers. Right, so I don't want to make them doubles. Because there are times when what you store should be whole numbers. But what I want to get from the whole number should be floating point. So this is mostly the place that you'll use for static. So you can say that static cast double y evaluates to 2.0, right? You put y into the static cast double machine and you get back 2.0 out. Right? And you can change that double, can also be any of the types, right? It could be int, could be char, could be string, could be bool. It could be anything. Now an int going to a double, what do you think that's going to do?
Add to 0.0.
Add a 0.0, right? Make a double, just add a 0.0, right? Right? Double going to an int, what happens there? Makes it an integer, what does it keep? Just the whole number, right? Does it round? No, right? Chunky. Good. There's 4 kinds. Let's not even worry about them, right? Just know that we static cast, right? Be careful though, don't static cast the whole thing, right? So you'll notice that when I was static casting, I was doing it on just one variable. If I static cast, right, to a double, right, x over y, right? Well, the value I'm going to get back is going to be a what?
4.
It's going to be 4, but not 4. What am I going to get back?
4.5.
4.0, right? Because x divided by y, 9 divided by 2 gives me what? 4 as an integer. And then I send 4 as an integer into my static cast to a double machine, and it adds a what? 0.0, right? So don't do this, right? Do what? That, right? Make sure that you're only converting the value.
You had it on the actually in front of him, so x divided by static cast double add y.
Could be on either side, right? As long as one or the other in division is a floating point, we get floating point. So that's typecasting, changing one from one type to another. And typecasting is you doing it yourself, okay?
So you have to do the expression while you're typecasting, or it doesn't do anything?
Now let's talk about type coercion. So typecasting is when we write it. Type coercion is when C++ does it automatically for us. Okay? I'll call it type coercion. I'll also call it automatic type conversion. Both of those kind of same idea. So basically, type coercion is the idea that C++ will sometimes coerce a value to be a different value. Okay, and we've already done it a bunch, and we'll show you where that happens. So the simple example is double D gets assigned a 5. D is a what type? Floating point number, good, right? And 5 is a what type of literal? Integer. Can you put an integer into a double?
Yes.
What do doubles hold?
Decimals.
Decimals. Is 5 a decimal? No. So I'll ask it again. Can you put an integer into a double?
Nope.
No. Can you write code like that though?
Yep.
Yes, that works fine. Why?
It does it for you.
It does you for you. Type coercion, right? It coerces 5 as an integer to be what? 5.0 a double, right? And so this happened automatically behind the scenes for you. If C++ knows how to convert it automatically, it will coerce it to be what it should be. That sounds mean, but I call it coercion.
It's like a rogue.
I'm going to coerce you into being something that you're not. I just want to be an integer. No, you're going to be a double, right? Because we said, right? We wrote the code. We said you're supposed to be a double. So you got to be a double. Right, so that's type coercion. Alright, look at some examples. What? We are not doing auto. The book talks about auto. We'll probably talk about it at some point, but not yet. I'm just gonna set some variables. And x is 9, right? Once again, do not name your variables this. Do as I say, not as I do. How many variables did I create?
3.
How many variables did I create?
4.
4. I created 4 variables. 3 are of type what? Integer, and 1 is of type.
The bizzle.
So, result and right is x over y. Right, result double is x over y. See out x. That's right. See out result n. And see out result double. I'm expecting my result int to output what value? The integer. What value should that be? Well, 4, right? What value am I expecting result double output? I am expecting output a double. What value am I going to get? 4 point what?
5.
5? Is that true?
Maybe.
What I get for both of them? Integers in a sense. Technically the double is still a double. We're going to learn here in a minute how to make it always look like a double. Why is my result double? Doesn't have the precision that I'm looking for. It's a double, right? Why don't I have the precision? The x and the y together, and they're both what?
Integers.
Integers. An integer divided by an integer gives me a what?
Integer.
An integer. I take an integer and I try to put it in a double, and what does C++ do? Coerces it, right? Puts a point out. Right? Which we don't see in Cout, because Cout doesn't give us that automatically. We'll see how to give us that here in a minute. So how do I fix? What did I try to teach you? Right, put the parentheses, throw the static cast in, right? So we can static cast. Right, to a double. Right, the value of y. And y, whatever value it is, needs to be inside of it. So now I'm taking x. Oh, I'll fix my double because I don't know how to spell. Double. Right? But I'm going to pass y, which is an integer, right? The value as an integer into my converts to double machine, and it will come out as a double. An integer divided by a double gives me a what?
Double.
A double.
Hey, there it is.
There we go. And so now my result int is 4, but my result double is 4.5.
A double.
Does that make sense? Why? Now they're right. One of them is a double. Is y a double or an integer though? It's an integer. Y will always be a what?
Integer.
An integer. That box that we created, when we created it on line 11, we said it's an integer box. So it will always be a integer box. But I can take the value in that box, right? Put it somewhere else, mishmash it through this machine and get the double out. Right? But y itself and the value stored in y is always a what?
An integer.
Always an integer. Let's see what else I want to do.
Like you only code alone.
I want to use that.
You want to see what
Yeah.
some of the conversions do? You kind of did this in your lab the other day, right? We're going to see how static cast, right, to integer, right, the character z. Right. So I'm passing a character into my machine, but I'm asking for it to be in what value? The integer value. Okay. And when I run it, Right, what do I get back? 90. 90 being the ASCII code for what?
Z,
For Z.
capital Z.
For capital Z. Right? Which means I can kind of reverse my example. I could maybe static cast to a character, right? And then this time pass in the value, let's say 100. Take 100 as an integer and convert it to a what?
Letter.
Right? Convert it to a character. So when I run that, I get whatever the ASCII is for 100, which happens to be
Lowercase d.
the lowercase d is equivalent to integer.
So would this be like if you were having user inputs of like them moving something with like WSAD, you'd want those values that way? To call
Possibly,
on
although
them?
you can always just check it versus the character. So it's only better just use the character, so you don't have to remember what it means. Once again, just showing there's a relationship between characters. It's kind of more interesting when you do stuff like this, like care, right? My care, not your character, it's my character, right? I can make it an A, right? And then I can see out my character, right? And then I can do fun stuff like this. This is good. Okay. I'm gonna put plus on the end. And see how it might do that.
Wait, why isn't it not?
So my character was A, but then what did I do to my character? I incremented by 1, right?
It's
So
that
the
one on
next
the
time
far
I
right.
put it in, it wasn't A anymore, what was it?
That one on the far right. That one.
No, but it's not.
Take in right,
changing.
or increment that we kind of learned earlier.
Oh,
Okay, I'm trying the care one. Do you need that to be in the single bracket
It has to be in
parentheses?
single brackets. If I put the plus here,
It doesn't like
what
that.
character am I expecting to have? Now put A, and then what's in it up? Right, A and then C, right? So it's
No, I
gonna
did.
increment my character once, and then it's gonna increment it again, and then he's.
No, I know, I tried that already, but I was just asking.
Questions?
It has to be.
All right, 2 more topics, and then we'll be done for today. First thing we're gonna talk about is console output, and then we're gonna talk about console input. We've used it, right, and you had to use it in your coding assignment, but I kind of just gave you stuff, and you kind of use it blindly, and hopefully you got it all working. All right, so let's formally talk about kind of output. We output with what? Cout, which is short for
Console
console output, right? Cout, console output. Right? Technically, it's std cout, so we use a using statement, right? Using std cout, so I'm going to type it right now. But it outputs to the screen. By default, with Cloud9, it outputs to the console. Right? That's where it goes. You can output pretty much anything that you want to output. What I mean by that is you can output any type that you want. Strings, doubles, pairs, ints, pools, they know how to output. Right? You can output expressions, right? 5 times 3, right? 5 times x, right? Expressions can output as well. Right? You can output variables, cout x, right? The nice thing about cout is that it pretty much handles whatever you want to output. Right? Whatever value you want to output, it will output it for you. And you can combine them and go real crazy with that. Right? Now, that being said, every time we change what we're outputting, right? I'm outputting a string, now I'm outputting a variable. Now I'm outputting an expression. We separate it with what? 2 less than symbols. Right? 2 less than symbols is the separator. Right? We call that the insertion operator. So the insertion operator, right, separates what I'm inserting into the console, right? Insertion operator separates what I put into the console. Right? No spaces there, right? So cout, 2 less than symbols, the insertion operator, and then in this case a string. The string says what? Hello world, and
line break.
a line break, right? So the next thing you output will be where?
The next line.
On the next line, right? The next thing I output is the next line. Right here I'm separating a variable, number of games, right, and a string literal, games played, right? Separating those 2. So I'm going to separate between things. What do I need? Right? Well, a semicolon goes at the end, but between the 2 things I have what?
Carrots.
Insertion operator.
Less than.
You could write this all on one line, right? But my projector doesn't allow me to go that far, so I have it down on 2 lines. Right? You'll notice, right? Is there a semicolon right here? No, right? So cout, 2 less than symbols, a variable. The next thing that the code hits is what? 2 less than symbols, then another string, and then a semicolon. Right? If you're going to write CL statements on multiple lines like this, right, try to line them up so they look nice. Your code looking nice is a good thing. You do arithmetic expressions like cout and then insertion operator, a string, the total cost is, another insertion operator, right, and then an expression. Price plus tax. Once again, an expression becomes what? A single value. That expression becomes a single value, a literal value.
Bless you.
And so what gets outputted is not price plus tax, but the value of price plus the value of tax. Right? That math done, and you get that final value. Is there 2 less than symbols at the end? No, right? Don't put less than symbols at the end. They separate everything, but the last thing doesn't have another separator, right? Just semicolon.
You're not using inline. Do you not need that at all?
You would need inlines if you're going to write more code. I just don't put it. But you probably should have.
You still need the lower, that's what you see.
Right, and then,
Okay, I was gonna ask, if you have the end line there, so that means you need another line after that, or you just use end line regardless of whether you're putting in more code or not?
regardless, right? It's just nice, right? Put an inline at the end, so if you're gonna output anything else, it'll spell on. Right? And I can put an inline right here too, right? The total cost is, and then an inline, and then price plus tax, and then another inline. Right? You can put them wherever you need them in order to make your output. Right? Because C++, hopefully you realize, right, it doesn't add spaces, it doesn't add line breaks for you. Right? You have to manually add whatever you want to add. If you want stuff on a new line, put a new line in there. If you want the things not to be next to each other, then add a space.
No coercion.
And so that's why you'll see that, like, notice this says number of games, but then my string, what does it have at the very beginning? A space. That way it says like number of games, 6, space, games, right? Not 6 games played, like 6 in the GR next to each other. Right, so you have to do that yourself, right? Manually add the spacing, the white space, as we would call it, that you want. \n inside of double quotes, or single quotes, or n line are the 2 ways to get new lines. Okay, so you can use either of those things to get line breaks. All right, here, the value is, notice there's a space, and then we'll output the value, and then we'll output a what?
STD.
All right,
Shit, I never heard of end line.
\n or endl, I don't really care, right? I usually use \n if I'm already in quotes, and endl if I'm not in quotes. Right, so here, fuel efficiency is miles per gallon, and then I say MPG, right, period, \n. This is what I'm already inside of quotes, and I want a new line. Here, right, fuel efficiency is, I output the value, I'm not in quotes, so then I output the end line. Right, both of those should be fine for you, \n. Right, cout comes in via IO stream, right, we learned that already. So it comes in with IO stream, and then, right, a couple of using statements. You could, so there's a way to say using namespace STD, but we don't like to do that. Because the namespace is really big, we don't want to do that in a little. Alright, you guys ready for some magic?
Yes.
Alright. So let's talk about doubles, floating point values, and how we format them. Right, if you think back to your last lab, you set pi to 10 decimal places, and when you output it in, how many decimal places did you get?
9.
I wasn't even
5?
like 6, right? 6 or 5. It wasn't a lot. Right? You're like, well, I know I stored it correctly, but now it's not outputting. So cout outputs stuff automatically for you, and so sometimes you want it to format in a certain way, and so we're going to learn how to do that with cout. Right, so here's price 78.5. Are we used to seeing money with just one decimal place?
Nope.
Right? No position of 2, right? So if I do this, right, what's price going to output? It could be 78.5, could be 78.50, could be 78.5000. We don't really know what's going to happen. We haven't really told it what. But if I'm going to output money, it would be nice if I set it to precision of what? 2, right? 2 decimals. Okay. So to get the output formatted correctly, you're going to do this. And I call it the magic formula. It's magic because we don't really know what it's doing. It just works.
What the hell?
Eventually, you're gonna look behind
It's
like
gonna have a lot of
curtain, right,
code,
behind the
yeah.
scenes, and then it's not magic. For now, you can just be
Oh, it's
Right.
telling you precision
shocked
2
and wondering
decimals.
off,
I
right?
did it.
And so, C out, which is our output, right? That's our output. Dot set F, and then in the parentheses, these two big long things, separated by a pipe. The pipe is shift backslash. Right? On your keyboard, it might not even look like a single line. It could look like two, right, vertical dashes.
Above the enter key.
You normally don't ever use the pipe until you get into a program.
When you get if statements and
Right? Yeah, all this stuff. Right? And then we'll use it a bunch for all sorts of stuff. So there's one pipe, right? iOS fix, iOS show point, fixed. I'll give you a little peek behind the curtain. Fixed to set it in fixed notation as opposed to scientific notation. And the show point to do what?
To show the
right?
point.
Show the decimal point. Then, after you do this one line of code, whenever you want precision to be something, you see out dot precision, and then the parentheses say how much precision I want. In this case, my precision is what?
2 decimals.
All doubles, right? Not just doubles, all floating points for the rest of my program will have a precision of
2 decimal points.
2 decimal points. Unless later on I say see out dot precision for in 4 or 5 or whatever. Okay, and we'll see that in code. It'll make lots. But if I want to change the precision, I don't have to redo this line. This is like setup. Kind of like SRAM was set up in our programming assignment. But you just do it once and it just works, right? Sets it up. So we do the setup once, we change precision, right, whenever I want precision to change.
This is something pretty common to use.
Yeah, because a lot of times doubles you want to look a certain way. Okay. These two lines of code are also, if you have that like laminated cheat sheet thing, it's on there as well. I don't know where on there, but I know it's on
I
there.
keep forgetting to go get that.
it's only like $1.
Spend $5, it's not too bad. C air is for console air output, just like C out is for console output. Right? C air is where you normally output like error messages. They both go to the same place by default, so they both go to the console. But there are ways that programmers can make them go other places, so it's nice to separate between C out and C air. Almost everything you output will always be C out, but sometimes if you have error messages, they're nice to be put on C air. But you use it the same way, just replace COUT with CERR, right, and does the same thing. All right, let's look at an example of this. Right, we're used to what Cout looks like, so that one's not too exciting. I say int num games is 5, right? It's Cout, right? Replayed. Right. Notice I'm gonna put a space, right? And then I'm gonna do num games, right? And then I'm gonna do another space and say games. Once again, separating my string literals with my variables with the insertion operator, right? And spaces, because if I didn't put spaces, what would happen? This number would be right on the D. It would be D, and then 5, and then what? G, right? Add some spaces so that it's going to work. We run it. Well, we get hello reader, and then we get what? We play 5 games. We could then also do something like this, where we could say int hand per game is 3, right? And then we say C out, right? You play, right? And now we can say hands per game times number of games. Let's begin. Okay. Trying to show that not only do you have to output like strings and variables, but you can also output expressions, right? Think how many hands per game, 3, multiplied by the number of games we played, 5. 3 times 5 is 15, right? So it should say I played how many hands? 15 hands. Right? Remember, when you do things like expressions, you either need to output them or store them in a variable, right? One or the other, or both, right? But if you don't output an expression or you don't store an expression, then nothing really happens. Make sense a little bit? And we're gonna go see out.
Yes.
All right, let's do a little bit more see out, right? We're gonna do the magic formula. Right. So I'm gonna double price to 78.5. I'm gonna see out price. Do the all-time price. Take a look next. I run that and I get $sign what? 78.5. Is that how I want it to look?
Nope.
What can I use? Magic formula, right? Let's sprinkle some magic in. See how that's set F? Right inside of there, STD, colon, iOS, colon, show point. And then the single pipe, and then STD, iOS, colon, fix.
The other one is the other way around.
It does not matter. It might be the other way around. Order here does not matter.
Do you need to put that before you call that?
You need to put it.
Does that need to be
before,
above?
right? So code works sequentially, right? So if you want if you want this to output with precision, you need to set your precision first. So I'm leaving this cout statement and then I'm adding the exact same cout statement. So you'll see this should still be 78.5. This will be something else.
That special character between show point and STD, how you type that?
Backslash, shift backslash. Right before the backspace. Looks like two vertical hyphens. So I'm gonna run this, right? And now I get 78.5 and I get what? 78.5 what? 0.0000, right?
That's a lot of
So
money.
it seems like the default precision was what?
6.
6? Which makes sense a little bit because in our lab the other day we got precision of 6. That seems to be our default precision. Can I change the default precision?
Yep.
Yeah, what do I do?
You type and see out precision paren 2.
Cout dot precision. And we want this precision to be what?
2.
2, right? I'm doing a little bit of quick typing. I'm duplicating a line with Control-Shift-D. Control-Shift-D to duplicate a line, and then when you're on a line, you hold down Alt. You can use the arrow keys and move it up and down all you want. That's how I'm doing. All right.
I just asked that question.
So hold down Alt on
That's
a line, I
creepy.
can just move it all up and down. So much. Now I finally expect my output to be what? 78.50, right? I set up my cout with formatting, and I set precision to 2, so I get precision of 2. I could, right, change the precision to be whatever else I want it to be. Right? We could have a precision of 10 if we wanted to. So now I should get precision, right, of 5 and 9. In your lab today, you will set precision to like 0, 1, 2, 5, right? You go all the way up to 100. And something weird happens there, and so in your lab, you'll figure out.
There it is.
Yes.
For the cout setup, direction set, is that first at the end of the line? iOS first.
No, fix. F-I-X-E. Once again, you have to do that before you what? Before you output, right? You have to set up your precision before you output, which is why on line 12 when we output, we get 78.5.
Yeah.
Because I set it up, but I set it up what? After. Code is sequential, right? The first code's always going to run before what? The next code and the next code, which is why you have to create variables before you use them. Right? You can't just create them whenever you want, right? You have to create them before you use them. You have to set up your precision before you output your precision. Just for fun, right? I'm going to change this to STD error, right? Which also outputs to the console screen. right? So notice I still get output, but this time it is 78.50000 whatever. What is it? That's 78.5. Now how's my precision? It went away. Why did it go away? What did I set my precision on?
See out.
See how, and what did I finally output on line 21?
Here.
Here. So that's a totally different place that it outputs, even though you'll notice that the output goes to the same place, right? But it's a different place. So if I wanted to put precision on C error, I would do, right, instead of C out dot set F, I would do C error dot set F. And I would do C error dot precision. C error is usually reserved for error messages, error output. Questions? We good there?
Yeah.
Right, so we did console output, so now we get to do what?
Console inputs.
Console input. Pretty simple, console input's not bad. All right, console input's done with CN for console in, right, console input. Arrows go the opposite way. So while C out has less than symbols, right, to go out, C in has what? Greater than symbols. Okay? I always do this every semester. I don't know if it's helpful, no one ever really tells me. Right? But the way I remember it is that when I see out, right, I do some less than symbols, let's say I see out X. Right? I think of my output going out of my program, so my output goes this way. Everyone with that? And so if I have two less than symbols, and my output's going this way, when it hits a less than symbol, what's it going to do? It's going to kind of flow around it. Everyone see that? So everything seems to be okay, and my flow's still going the right way. If they were greater than symbols, and my output was going, what would happen? Get stuck, right? So you don't want your output to get stuck. So they're not greater than symbols, they're what? Less than symbols. And then remember what CN is, it's just the opposite. Right, it's the opposite of CN.
You could say C out requires less people than C in.
There you go. Get some kind of mnemonic for you. All right, so it looks like this. CN, two greater than symbols, and then on the right of CN is the variable that we want the user's input to be stored into, right? We need a variable, it has to already be created. That's what we're going to store the user's input. Remember, the two less than symbols was called the insertion operator. The two greater than symbols are called the extraction operator. C out inserts output into the console. CN extracts out or input from the console. Right? You extract from the console. You insert into the console. You can actually get more than one variable at a time by separating with more extraction operators. So you can say CN, right? Extraction operator num1, extraction operator num2. Right? This says get from the user. The first thing you get, they'll put in num1, and the second thing you'll get, will put in what?
Does that naturally line break?
Not a line break. So we're going to talk about line breaks and all that.
Because I remember us doing like an input when it said pick a number or whatever, and it would always do a different line.
Right, and that's because when you get input and you hit enter, your next output will be on a new line. So you hit enter. But here you actually hit enter once. So let's talk about how that works. So I think we know in a CN statement, right, when you're getting input from the user, the program stops. Right? Because it's running really, really fast, and then all of a sudden I need something from the user. So it stops and it waits for what? User input. And the user input is the user types something and hits what?
Enter.
Enter. Okay? That's going to set the first thing you wrote to the first variable, right? The second thing you write to the second variable. Third thing you write to the third variable. All right? But it's not going to read anything until you hit what? Enter. Right? So you have to separate multiple input either with spaces between or type something, hit enter, and then type something else and hit enter. Some things to note. Okay, if the user input is supposed to be an integer, like in our number guessing game, right? I create a variable of type int, and I'm expecting the user to give me a value that is of type what? Integer. Okay? Does that mean the user will give you a value of type integer?
Not always.
Not always, right? So one thing to know in programming is you never trust the user, right? Users are dumb, right? They're going to give you the wrong thing, right? And so on Wednesday or Thursday, we'll learn how to get the right stuff.
Learn how dumb they really are.
Right. But for like your guessing game, it's okay if the user typed in hello when you ask for a number between 1 and 10. I'm not going to test for that. We don't know how to deal with that. But come Thursday, we will know how to do it. In your next assignment, that's the expectation. But the user will only be able to give you values that you want and nothing. No, we're just. Okay, that's it. CM was easy. Let's do a quick example. That's not right. Alright, num1 and num2. Everyone good that my examples use integers, but you can always use them with any type that you want. Right? Please enter a number. You should always precede a CN statement with a what? COut statement, because the user doesn't know what your code looks like. Your user doesn't know, right, what you want. So I told them to enter a number, and here I got the number, right? CN says get from the user, store it into that number, right, and then I output. So they're going to input something, and then we're going to output. So I enter a 5, right, and I enter a 5. Okay. You can run it again, right? If I enter hello, right?
You enter 0.
But in fact, it also breaks some other stuff, right? But right now, you don't have to worry about that. We're going to learn how to fix that on Thursday. We're going to make this really bad English. Please enter a numbers. Right, you say, see in here, 2 greater than symbols, and then num2.
Please enter numbers.
Enter some numbers. So 2 ways to enter multiple numbers. I could enter like 5, and then hit enter. Notice it's still waiting. I haven't got any more output. Right, I'm not going to input 10. Hit enter. Or I can do the same thing and enter a 5 space 10. So 5 space 10, hit enter. Alright, and that'll give me all of them. Alright, so 2 ways to get multiple input. Usually you don't get multiple input because users aren't used to doing that. Right? We're expecting, right, 1 line of code to get 1 thing. Some of you, I think, have already done this, but I'm going to help the other people that haven't. Right? CN is not COut. So you can't say like end L. Right, after input, right? If you want to do an inline, you don't use CN, you use what? Slash. Okay. And it's terrible because, right, I didn't really add much code. I just 2 greater than symbols and then end L. Right? I'm going to make this like this because when I run it, what I get is this horrible, nasty error message. Right? And you think that was bad, but just watch as I scroll up.
Oh my God.
It's still going, it's still going, it's still going.
Whoa.
It's still going, it's still there.
You added 1 extra chromosome.
And in fact, right, I didn't even make it up all the way to the top. Or no, I did. I made it all the way to the top. Right? You'll notice that the error message, if you make it to the very top of the error message, it actually tells you what's happening. Right? The arrow, right, the caret is pointing to the error. Right? But this is just gibberish. Right? So don't mess up. That happens when you mess up your greater than and less than signal. So just don't mess up your greater than and less than. Right? But then all you have to do is get rid of it, and then it all works fine. So end lines are not for input, they're for what? They're for output. Right? You automatically get a new line when you do input because when you type something, what do you hit? Enter. So the next thing's not one.
Want to give me both of them.
You entered 2 and 2.
Questions? We good there?
Yeah.
You want to feel like I've been talking a long time?
I could do 14 and 7.
All right.
No time on that.
Let's look at your lab.
It's too far.
Because you just add that strip right there with that.
All right, question 1. Fix the following code to get a floating point answer. Hint, you need to convert to integer literal, right? I want my answer to be the decimal, right, a floating point value. So you have to do something to this, either x or y, not both, right? X or y, to make them a no. We learned how to do that. Question 2, I want to talk about because this is going to happen a lot more throughout the rest of the semester. Question 2 says, what is the output of the following C++ statement? Now, I could just copy paste that code, put it in Crowd 9 and run it. Will it give me the output? Yeah, right? It'll just work, right? So you can get the answer. It's not that hard to get the answer, right? But you'll start seeing when I ask for output, my goal is for you to be the compiler, right? So the goal is for you to read that code and figure out what it would do, okay? So I would write in your answer sheet what you think the answer is, then run the code in Cloud 9, right? And if the answers are the same, great, right? And then you got 100% for that question. If they're not the same, right, fix the answer and figure out why it is that you got the wrong answer. We're going to get a lot of that, like what is the output, right? The goal for you first is to kind of compile the code in your brain yourself, right? And then you can compile it. Question 3, you need to write a cout statement that will output those 2 lines, right? Notice 2 lines, right? Those are not on the same line. So your goal is to write that with the cout statement. Question 4 is all about precision using the magic formula. You're going to create a double, give it a big value, right? Output it with precisions of 0, 1, 3, 10, 20, and 80, right? Kind of compare all the outputs and figure out something's going on there.
Number 3, you want to put the output statement here instead of place the code that you want.
Right, but for output statement, I want the code for the output. So cout 2 less than 7. Yeah. 5 and 6, same thing. What is the value of the answer after the code is run? Right, run it in your brain. Right, be the compiler, figure out what it is, then check your answer. Right, because if you put that in code in main, it will give you the answer. Right, you see out. So I don't ask you what the value of x is. I ask you what the value is what? Answer. Because for both of these, the value of x is going to be what? 6, because 5 plus 1 is 6. No matter if you increment it after or increment it before, it's still going to be 6. I'm not asking for the value of x, I'm asking for the value of the answer. And then remember what that thing's called?
Oh, insertion.
Insertion operator, maybe? Yeah. So that's your answer to 7. That's what we have for lab today, 1 through 7. All right, what I would suggest you do for homework is to read through assignment 2. Okay, I am not going to present assignment 2 today. I'm going to talk about assignment 2 on Thursday. So your goal is to read through assignment 2. So when I talk about it, you might have some questions already formed about what the heck we're doing. Assignment 2 is not due for about a month.
Whoa.
Okay, so it's a little bit bigger than just a simple month.
Which ended up being really simple.
Yeah, right? You can break it down. And you can break it down. It can be real simple. Yeah.
In my head, it was like, and then you realize, yeah, that's extra credit. You're good.
You're good. You're all good. Questions? Also, make sure right before you leave today that assignment 1 is on GitHub. Right? I'm gonna start grading it. If there's no code there, then you're gonna get a 0.
I think mine already got graded.
Yeah, mine too.
Oh, you're assigning it.
Yeah, I got like a 50 out of 80 or something.
If we
like
turned
that.
it in, I think you graded it. The labs.
I have a grade. The labs are graded. Your code assignment is the only thing that you've turned in yet. So your labs should all be graded. But code assignment 1.
I got like 50. Oh, that's not graded yet.
Oh.
Yeah. All your labs should be graded, right? Labs 1, 2, and 3. I think they're all graded.
Word.
Are you on grader? All right, so always check your grade. All right.
I can't believe I got a 45.
Neither am I.
I got a
But check your grade, right? If you feel like it's
49.
down for something. then-
Kenneth is a stickler.
Yeah, probably. It normally happens. It's former students. Former students are always different. Right? They always are.
You put a space between your semicolons.
I'm willing to work with you. I'm a little bit nicer. All right, so check your grades. If something seems like I don't think that's wrong, or I lost 25 points and all I did was miss a semicolon, right? Then let's talk about it. All right, sound good? Questions? Before you leave today, make sure you sign the sign-in sheet that I am passing around. I'm passing out a sign-in sheet. Make sure you sign it before you leave today.
Okay.
I know you.
Word. elaborate way.
To get a floating point answer, which means you want to get an answer with decimal, right? Right? You just have to put static.cast and then you have to put the y in parentheses. Or no, you put static.cast and then double in like those less than greater than symbols.
Yeah, but which one are you wanting to
No,
float the y, right?
Yeah, you can float the y or the x. It's just the answer has to end up as a decimal. So it would be easier if you did the y. You just put static.cast and then in brackets you put double.
Right. Yep. So a lot of this isn't really done on CSCI, huh?
No. I almost fell asleep because it was so easy.
Don't be over-dramatic.
No.
God damn it, no.
No, so the 2 times 5 gives you 10, that's what gets scored, and then x becomes
Fix the following code.
Is it static.cast?
The plus doesn't affect
You know what? I
your
can tell you.
expression, it affects
Oh, I think I typed it here too. Yeah, so it's
static
underscore cast. You want to use double.
Yeah. Alright, thank you. No, it's way down here. It's a ballpoint pen.
Yeah. Smoothness.
Mm-hmm.
What is the output of following?
You have blank number of pods, blank, you can quit. That's basically it. Oh,
I don't think there's any lines.
no, it's outputting it on the same line.
Yeah.
Yeah, that's what I did. Write an output statement that will produce the following message. That means we just have to write like C out, all that for this. Like C out, answer the question of.
I forget to use that one.
Have you ever heard of Sea of Thieves?
Yeah, I have.
It's gonna be for PC. But
It is
no.
on, it is on PC, I think.
Yeah, it's on the Windows Store though. It's not on Steam.
No, I don't think so.
It's only for the Windows Store and the Xbox. So you can technically still play it on the PC. It's just that you can't do it through Steam. And people who play PS4 are getting outrageous. They're just like, hey, you should totally bring that to our console. And Microsoft already confirmed they're not doing that. They said, screw you guys, come to Xbox. They're writing a petition to get it on PS4. I don't understand it.
Right, is that how you would write it? I would line them up, line break.
I just put end line. You could do that. Because the line break is the same as end line.
Yeah, but I want to get used to using it.
No, you can do /n and then continue to write life, the universe, and everything is 42 on the same line after you put the line break. So you don't have to put another insertion operator. If you put
But
/n.
what I want is clean code. I don't want it to be 10 lines
Yeah.
long. Does that make sense?
Yeah.
Yeah.
Do you get what I'm trying to do? That way it's readable.
Yes. I don't think you need a semicolon there though.
I don't know.
No, you don't. Because you've already put another insertion operator, you just pressed enter.
Okay, that means that. Okay, yeah.
Yep.
Because I'm looking at it, I'm missing. There's one thing that I'm not liking on this.
I just made a variable for the number 42 and then just put another input as number 1.
So for created double variable.
Hey, did you know in Notepad++, if you highlight something that's like the name of something like integer, it'll tell you where all the other ones are.
Yeah, I think that's really cool.
Yeah, I think we can come back.
Let's see. It wants us to do what again?
It's just to write that number and then try to output it in different double lengths. But then we have to write that really long thing that I've already forgotten.
The spell, right?
Five and six, you just have the volume of the mainframe, not the volume
I just want the value.
One's an answer. Number 1. The way I read it was it wants you to fix it. That's what I took it as. Yeah.
What the fuck? Such a long name. 3.141.
Just
5.
copy it.
Yeah, I could do that.
Control V.
So then we can go up.
Let's Control C.
Well, no, I'm saying you paste it with.
Yeah.
That one wasn't being able to paste it with right click, so I just Control V.
I'll just call it pi. Double pi. And then we gotta type that really long thing. Let me just open up the lecture and then find that.
Well, that's why I was kind of coding along, because now I just have it.
Well, I remember how it goes. It's just that I forgot one of the phrases, like fixed.
Yeah.
I opened up the wrong lecture. There we go. Got it. Set F, STD, 2 colons, iOS, and then show point.
Okay, so it wants us to do.
Your program ended with 1. Oh, there's a semicolon right there.
So for now, like for every assignment, you can just override whatever the original one was.
Your program ended with 1. See out.setf is incorrect.
Well, the see out, like by sending the decision, cut off the decision like longer. So that should be that. I don't think the more it's gonna round, it just will round it for you. Now what precision is that? It'll round.
Is there a hotkey for a run? Like a
Alt F5?
Alt F5?
Yeah, if you're in your code, Alt F5 will compile and run.
This
Oh,
is
thank God.
3.14.
You don't, may not believe the keyboard.
Alt F5.
Yeah.
Alt F5. This is 3 point. 3 point?
Feels like Fortnite.
Nobody likes Fortnite.
I play Fortnite.
You have to play PUBG.
PUBG?
Yes. There is a paywall, but it's a good game.
This is the
Fortnite, bruh.
Well, it's kind of the same. It's the same thing.
You can play it with any. You can play with PC.
Yeah. You guys play Fortnite?
Um,
Lame.
Go to lectures. Or just maybe take lecture.
I'm not very good, but I have fun.
Yeah.
If I play with some buddies, say we have squads. Not right.
well, you know how you had to make your account and then make a PS4 account? Yeah, what is yours? Just you don't even remember?
I'll just write it in.
Oh, okay.
You don't say it like that.
Elitist.
What?
I said elitist.
What does that mean? What's that supposed to mean?
It means you're like, PUBG, you're that fan. You know, and you're making friends. And we're like, hey, let's be friends and play together.
I can't play with you guys. I don't play on PS4.
I play on PC. I don't even own a console.
Oh. I also play on PC, kinda. But I play mostly Xbox. Unfortunately, Sea of Thieves will never be on PS4. How unfortunate. Or PUBG. I've seen some elitists when I was chatting in this YouTube's the live stream. This person was playing Star Wars Battlefront 1 on PS4, and I'm like, join the Xbox side. and I was like talking to this person in the comments. He's just like, oh, PS4 is way better. And I'm like, you guys don't have PUBG. And then the streamer was like, oh, it's coming to PS4. I said, no, it's not. No. And he's like, well, what about CFP? I'm like, no, it's not coming. That's not going either. What is number 5? What is the value? What is the value of answer? That'd be 10, right? Just be 10.
No, it'll be 11. Because it's after.
Oh,
Plus plus
are
after, so
you
it's gonna
sure?
be 2 times 5 and add 1
Because
to
I thought if it was like this, it would be.
Plus plus is after your variable.
Oh, so then it would. No, if it was after, then it would have multiplied the value of x in 2 and then add the value of x at the end.
Yeah, which is 11. 10 plus 1 is 11.
No, I'm saying it would multiply 2 times the value of x, and then it would push that to the side, and then do x plus plus, because the plus plus is tied only to that one variable. So it wouldn't change the value of answer. It would only change the value of x, because the plus plus is only tied to one variable.
Okay, I see what you're saying.
So it would multiply 2 times 5, and it'd be 10.
Right.
But it'll add 1 to the value of x, but we don't want to know x. Yeah. And then if it comes before, I don't remember. I think it's. It comes before, so.
It won't, this works, that doesn't, not often how it's like.
Wouldn't that just. Wouldn't that make it just 12? What happened? See, it's 10 because it adds the plus plus is tied to only the variable. Actually, just switch it around because I want to see because I
am right now.
Yeah. 12, right? Yep. Because then, since it comes before x, it will make the value of x 6 and then multiply by 2. I don't understand. I like how it says you can turn this in on Thursday, but I can turn it in right now. Insertion operator. Well, good for you. I bought a GTX 1050 Ti off a guy off eBay, and then I realized he lived 10 miles away from me.
Oh, that's kind of creepy.
And then he was just like, oh no, I told him, I said, dude, I live like 10 miles away. You don't have to ship it, and then it takes like 3 days to get through the freaking shipping, all that shit.
He's like, bye after school.
He's like, oh. So we met up in the AutoZone parking lot, and I discussed other graphics cards he had, and the highest he's got is like a 1080 Ti, and it's like almost $1,000.
No, cryptocurrency mining and stuff is shot up the price of everything.
Yeah. You know, I see on eBay a lot, they're advertising, hey, this is good for cryptocurrency mining, and I'm like, I don't want that. And then there's a guy who's selling 6 for $3,500. And I'm just like, what the fuck? I don't want to do that. And then people get these huge towers that have like 10 slots, and then they just stick all graphics cards in there, and then they do their Bitcoin mining, which is almost pointless. It's bullshit. No, yeah, it's training on lab 4. Begin assignment. How dare you? And my friend Devin has a mini 1050 Ti, and he doesn't have the power from his power supply, so it gets really hot and it uses a lot of energy and it burns out the PCI Express port. So he was running one of his Oculus Rift games, and it was bottlenecking at 100% GPU usage, and I'm like, whoa. Think you could maybe upgrade a little bit?
Yeah. That's Corsair with the cooling and everything.
Oh, that sounds expensive.
Not too bad. Built a beautiful rig.
Well,